Okay, last video for Cal 2. How exciting is that, right? So we're ending with a Taylor polynomial. So I want to approximate f of x equal to e to the x squared. Ooh. By a Taylor polynomial with degree 3. So this is a T3 of x, okay? At some number, at the number c equal to 0, so this is a Maclaurin, okay, so centered at c equal to 0. Estimate with accuracy x between 0 and 0.1. All right, so want to see how accurate it is on that interval. So what do I need to do? Well, I need to calculate T3 of x. T3 of x is n equals 0 to 3. We go out 3, right? So f n c over n factorial x minus c to the n, right? Now, for this particular one here, what is it? It's, f of c over 0 factorial x minus 0 to the 0 plus f prime of c over 1 factorial x minus 0 to the 1 plus f double prime of c over 2 factorial x minus 0 to the 2, and then plus f triple prime of c over 3 factorial x minus 0 to the 3. Okay? So what do I need to calculate? I need to calculate f of c. I need to calculate f prime, f double prime, f triple prime. So let's do our little table. Okay, so 0, 1, 2, 3. And I've got my function. So I got my f of x. And then my last one is going to be the function evaluated at f of x. Okay, or at f of c. So my c here is c equal to 0. And my function is f e to the x squared, right? So the function itself, f of x, is e to the x squared. So this is e to the 0 squared, which is e to the 0, which equals 1. Okay, so my first one is 1. The next one, okay, what's the derivative? F prime. Okay, it's a chain rule, right? E to the x squared, that's a 2x e to the 2, or x squared, right? Okay. Now, if I evaluate this f prime at 0, what do I get? I get 2 times 0 e to the 0. That's 0, right? Multiply anything by 0, you get 0. Oh my goodness. Okay. So then f double prime, I'm going to have to use a product rule. So first times the derivative of the second is e to the x squared times what? 2x, right? Plus the second, e to the x squared times the derivative of first, which is 2. Holy cow. F double prime of 0. Well, that first piece is 0. Okay, if I plug a 0 in, I get 0. The second part is e to the 0 times 2. So that's 1 times 2, which is 2. Okay, so not too bad. So the first one's 1, the next one's 0, the third one's 2. This last one, triple prime, oh my goodness, this is just getting so complicated, right? Okay, so let's see if I can, before I take this derivative, let's see if I can simplify it, make life a little better. So f double prime is, well, 2x and 2x makes 4x squared, e to the x squared plus 2e to the x squared, okay? So triple prime, what's that going to be? Let's do the first times the derivative of the second, e to the x squared times 2x, plus the second, e to the x squared times the derivative of the first. That's 2 times 4 is 8x to the 1, right? And then The next one is just 2e to the x squared times 2x. Okay. Can I clean this up? 2x and 4x squared, that is 8x cubed e to the x squared, not cubed, plus 8x e to the x squared. Okay. And then plus 4x e to the x squared. Well, what can I do with this? I can combine those to be how many total? That's 12. So that's 8x cubed e to the x squared plus 12x e to the x squared. Whew! A lot going on there. That's just f triple prime. If I plug in a 0 for f triple prime, what do I get? Looks like I just get 0 plus 0, which is 0. So plugging in isn't that big a deal, plugging in a 0 there, right? Oh my goodness. All right, so let's see if I can summarize what's going on here. So let's take this and I'm going to move it down here where I can see it. Okay. Oh man, I can't even fit it in there. Let me make that uber small. All right. So what do I know? F of 0 is 1. So this is 1 over 1. And that's all raised to the 1, raised to the 0, which makes it 1. Plus f prime, which is 0. So that whole term goes away. And then I plug a 2 in. So that's 2 over 2 factorial, which is 2. And that's x squared. Okay. And then plus, and then this last one is a 0, so this whole term goes away. So what do I get? I get 1 plus x squared. Oh my gosh, are you telling me this whole complicated t3 of x is equal to 1 plus x squared? Are you joking me? It's simplified down to that? No, I'm not joking you. So look, I can approximate f of x equal to e to the x squared with t3 of x equal 1 plus x squared. Let's graph both of these on the same graph and just see what it looks like. I'm curious. I don't know. Let's do it. See what happens. Why not, right? We got a calculator. So let's do e. Oh, that's a log. So second e to the, let's see, what are we doing? X squared, enter. And then what was our T3? It was 1 plus x squared. Let's just see how good of an approximation. Oh man, that doesn't look too bad. When I get really close to 0, it looks like my curve is approximating it pretty well, right? It actually looks like a pretty good approximation for x close to 0. Now, once we get away from 0, it starts to not look like a very good approximation, as you can see right there. Okay, the further we go out, the further the error becomes, right? So, pretty interesting. All right. Now, what else do I want to know? I wanted to get my Taylor polynomial with degree 3 at some number here. Now, notice here, this is not a degree 3 polynomial, okay? But it is, we did go out 3 terms. It just turned out that third one there, had a coefficient of 0 that made it go away, right? So keep that in mind there. The n, okay, this tells you how many terms to go out to. Okay, it doesn't necessarily mean that you're going to have a degree polynomial equal to 3. Okay, so what if I want to find, how accurate this thing is? Well, what do we have to do? We have to go back to our theorem. Rn of x, right, is less than or equal to absolute value. What is it? It's m, right? So we got m over m plus 1 factorial absolute value x minus c to the n plus 1, right? Where m is your function, n plus first derivative evaluated x. Okay, it's the maximum that function obtains. So it's the max value on the interval. Now, what interval are we considering for this problem? We're only considering x values on this interval here. Okay? So how are we going to do this? All right, well, one way is to just look at the function, right? So we got to figure out the fourth derivative. Well, to do that, we need the third derivative, and that's the third derivative there. So I'm going to copy this down. Okay, so that's f triple prime. All right, so let's get the fourth derivative. So f fourth. Okay. Whew. I can either go through all this work or I can just give you the answer, right? I think I'm just going to give you the answer. This is 12e to the x squared plus 48 x squared e to the x squared plus 16 x to the fourth e to the x squared. Now, it might be good practice for you to run through the power rule, chain rule, product rule, all in that, okay? Couple of them multiple times, right? This will simplify to e to the x squared times, I can factor an e to the x squared out of all those, 12 plus 48x squared plus 16x to the fourth, okay? Now, what do I know about this function? This function, okay, is increasing on 0 to 0.1. Okay, it's increasing on this interval, right? Now, what does that tell me? That tells me the maximum will occur at x equal to 0.1. If this function is increasing on that interval, and you can throw that in your calculator and graph it, and you're going to see that function is increasing on that interval, okay? So x equal to 0 to x equals 0.1, the biggest the function gets is on that right endpoint there. Okay, it's an increasing function. How can you tell? Mathematically, you could take the derivative of that again and show that it's positive. It's always positive. It's increasing, right? So all we got to do is we just got to plug in 0.1 into our function, and we get e to the 0.1 squared times 12 plus 48. 0.1 squared plus 16.1 to the fourth. Hit that into your calculator. Oh my goodness. That number's a tiny little number, right? And then we have what? In here is 3. So that makes this 3 plus 1, which is 4 factorial. So what do I have? R3 of x, absolute value, less than or equal to m, which is this nasty thing here. Okay, so it's this thing right here, divided by 3 plus 1 factorial, that's 4 factorial. And then what do I put in my absolute values? I put, well, x is 0.1. minus my c, which was centered at 0, raised to the 3 plus 1 here. Okay? So I type that in my calculator. That's equal to, let me copy and paste this because it's a lot to write, over 4 factorial times 0.1 to the 4. When I type that in my calculator, I get roughly 0.00006. So what is this telling me? The maximum error that can occur by using T3 of 1 plus x squared on the interval from 0 to 0.1, the max error that's going to occur using this simple function to approximate e to the x squared is this right here. That's the maximum error. Am I saying I'm going to get that max error? No. But I'm just saying that's the maximum error total. And remember, if we go back to our graph, we look at our graph, the closer we are to 0, the closer those dots are to each other. But as we go further and further away from 0, my x goes further from 0, my dots become more and more spread out from each other, okay? And so that means our error, the difference between those two dots, is increasing, right? So as we're really, really close to 0, like an x equal to 0.1, right? Oh, that's a little bit too big, but you kind of see, okay, so 0.06, that's less than 0.1. You can't even see the difference in those two dots there. It just looks like one black dot, okay? But as you go out here, then your error increases, right? Okay, guys, I hope that cleared up calculating maximum error problems for you. Good luck.